In the previous video, we were looking at this function here, 1 plus y, as a density function, and we interpreted the double integral as the mass of this region, D, given by the semicircular region. We showed that the integral that we needed to do, the double integral, was given by this, right? And then we showed the interpretation of that as a mass integral. And we went through with showing the different plots in Mathematica, how to interpret this function. Instead of as a 3D volume, we interpreted this function as a density function. So the subject of this video is going to be to just kind of get into just do a really quick example of the nuts and bolts of how do you actually compute the double integral, right? So the integral we wanted to compute, let's see, was on the previous screen. Right, here is our double integral we want to compute, right? So let's get this into the computer. The simplest way to, well, I'll just show you two different ways, okay? One is just to go straight at it and say integrate, right? The function we want to integrate is the function x and y that we defined above. And then we want to do this as a, there's two integrals, so we're going to be first doing the integrate with respect to y integral. And then we want to integrate from 0 up to the square root of 4 minus x squared. So this notation here, okay, I'm putting a little text, a little message for you. What we've done here is we have, bring up the writing assistant, you can see how this works. We're here on the side. This brings in what we are trying to do is we are computing the integral y equals 0 up to y is equal to the square root of 4 minus, fine, I'll make this as pretty as I can make it, the square root of 4 minus x squared. Okay, and then the function we were integrating was 1 plus y. And then we were doing this as an iterated integral, so there are two integrals we have to do. So the command below will be doing this integral. Okay, if I've done this correctly and hit Shift Enter, I didn't do it correctly because I'm forgetting a closing bracket here. You could click this box and it may give you a message. Oh, well, there it evaluated. Okay. So here, notice that when we integrated our function of y, right, as a dy problem, we now get an answer that has only x's in it. Okay. So this, we could call this step 1 if you wish. Okay. Now if you go to step 2, you would then have to integrate the result from step 1. Step 1 is given by this answer, and I need to integrate that with respect to x from -2 to 2. And this, after the second step, we should get a number, okay? And the number for Mathematica is this nice non-decimal answer with exact arithmetic, 16/3 plus 2 over pi. Okay. So this step, the second step, we computed the integral. Where was that integral? Right over here in the writing palette, from x equal -2 to x equal 2, and we integrated the function 2 minus x squared divided by 2 plus the square root of 4 minus x squared. And we integrated that with respect to x. And because we had only a function of x here, we were doing a dx integral, and we had our x bounds as numbers, we got a number out of that called 16/3 plus 2 pi. If you want to convert step 2 to a number, you just say //n, and that will turn that to a decimal, or you could say numerically evaluate n step 2 to a number, and that would give 11.65. Okay. So there's how you do the double integral if you're typing it out as an integrate. I think you can see that I have been using the writing assistant. Okay, and that is under palettes, writing assistant, and that'll bring up this box. And let me try this. I sometimes have difficulty here, but let's see what we could do. This symbology will actually evaluate it for you. Let's try this. Let's put in an integral, and let's put in, no. Let me see, can I do another one of these? Integral. Okay. So we've got two integrals, and we just need to fill in the boxes now. Let's put in the function 1 plus y here. Let's put this as, and you don't need to put the x's and y's, we need to put just the bounds here, 0 to the square root of 4 minus x squared. And then our bounds were -2 to 2. And you do need to say the integration order here, it's dy dx. And I'm hoping that if I put shift enter here, I should get the same answer as if when I did integrate and integrate. So if you'd like to see the partial integrals, you can break it into 2 steps. This doesn't seem to be working. Put 1 plus y in parentheses. I'm wondering if that will do it. Could be wrong. There we go, that worked. It looks like I hadn't separated 1 plus y from the dy dx. And there is your answer in one step, kind of just filling in the blanks. Okay. If you want to get that to a decimal quickly, you just put any of your answers there as decimals, and it should convert it to a decimal. So there's how you can check your answers with Mathematica as integrate or the writing assistant palette, and you have access to a large variety of just simple pick your, you want to do a partial derivative, you want to do a derivative, here's one partial derivative, you want to do a sigma notation sum, and you have quite a few options to help you with your symbolic computations. So that'd be the end of this video. I think we've talked about the different interpretations of double integrals, and we have continued with showing you how to actually check the integrals that you are doing by hand. Right? Just remember that Mathematica is not a panacea for everything, because it has troubles with the same integrals that you would probably have troubles with. For example, if you asked it to integrate the exponential function of minus x squared, and you ask it to integrate that with respect to x. Well, e to the minus x squared does not have an antiderivative, and because you know that, the computer also knows that, it will not be able to find that as a function that you probably recognize. This is the error function, ERF, and that is the actual meaning of this function, integrate e to the minus x squared, as an error function. Right, so even with the computer, you have to recognize that it has some limitations. Also with integrating the function, the very important function, sine of x divided by x, integrating that with respect to x, that's the sine integral. So yes, there are integrals that are not doable even with the computer, and the computer knows how to work with them, and as you progress on with your mathematics career, you will figure out how to work with some of these integrals. The error function shows up a lot in statistics as the area under the Gaussian function, which is this e to the minus x squared. The sine integral shows up in the Gibbs effect when you get into Fourier series and Fourier integrals. This sine integral plays an important role in the Gibbs effect phenomenon. All right, so just realize the limitations of the computer and how to use it as best you can to check your answers, but you will need to be able to do the necessary integrals by hand, but it is a good idea to be able to check them with the computer also. All right, end of that. Have a good day.